Sometimes to really learn and grow as individuals, you need to look inside and evaluate. Which means to continue the SQL join series, we're going to look in to the inner join on today's chapter of DataBard. DataBard, 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 hoi, hoi, hoi. What you're seeing here is an excerpt of a full-day SQL training workshop from the basic fundamentals all the way up to some pretty complicated scenarios in 8 hours. So tell me if you do like this content, because if you do, I do have more that I can make videos on. Let me know in the comments. I'll be sure to make those sorts of things in future videos if you think it'll be helpful. Now that we've got the structure of Lego bricks that gives us the ability to join, how do the joins themselves work? Here's how joins work in a nutshell. First of all, joins are defined by predicates. To be clear, when I'm talking a predicate, I mean this information on the upper right corner of your screen. On a.keyColumns equals b.keyColumns. What's a predicate? Predicate means I take a formula and I can assess whether it's true or false. For example, does the number 2 equal the number 2? I can assess whether that is true or false. 2 equal to 2? That's true. 2 equal to 4? That's false. Okay? So we know that a join requires a predicate. How does it use the predicate? Like the following. When you define a join between two tables, we look at them as A and B in the same way that the Venn diagrams do. So we define the join on a predicate. What actually happens though behind the scenes? Well, we know starting out that table A is going to have so many records, table B is going to have so many records. What happens in a join is all of the records in A get compared to all possible records that exist in B, and we essentially create a logical Cartesian combination of all possibilities of a record in A finding a matching record in B. For all of those combinations, we then assess each combination of records, and we assess for the predicate, does the predicate succeed for the record or does it fail? Depending on the result of that determines what we get back in our result set. Now, in the shift from a join that has no predicate to a join that has a predicate, an important thing occurs. You remember from the cross join that we essentially get a Cartesian product. Multiply the records of one table with the records of the other table. That is the total number of records you can get back. When we get to joins with predicates, we're no longer dealing with two dimensions and the multiplication. We are shifting to a single dimension, or really a line, where we are trying to join these records once to these records over here once, and depending on what we find, that is what we get. Let's be clear about what I mean about success and failure. What does success and failure mean when we talk about the predicate? Success means we find at least one matching record, which means for a record in A, we find at least one successful record in B. That is considered success. Failure means that a record in A looks in B to find a corresponding record based on the predicate, and it finds no match whatsoever. Now, knowing the definition of success, when we have a record in A successfully join into B, those two records now merge together into one really wide row that has all of the columns in A and all of the columns in B for each success. First tip when you're defining joins is your joins have to be very specific, because it determines how many records you get back. If I have a record in A with a value of 1, and I have two records over here that both have a value of 1, A is now going to get duplicated to create two total records. where the columns in A are duplicated and the columns in B are unique. When I'm working with a client and I have to debug queries, more often than not, the first issue that you have to resolve is identify if your joins are innately creating duplicates by not having predicates that are well defined enough. Once you solve that, more often than not, that solves your duplication issue. So this is logically how joins work. All the possible records in A compared to all the possible records in B. What's the rest of the terms for? I haven't even talked about inners, outers, lefts, rights, and whatnot. What differs, and where we then start adding in those words, is what we want to do with records that fail the join predicate. That's the only difference between them. Logically, all joins do the exact same thing that I explained. All records in A compared to all records in B. The only difference is, based on that comparison, we return a different set of records from that comparison depending on the predicate and the type of join that we define. Don't believe me? Let me showcase it in a demo. So again, we started with cross. Cross returns all possible combinations. Full adds in a predicate, and if the join fails, we return the record at least once. Left now restricts it to say we are only going to return all records from one table, and we are going to ignore some records in our right table if they don't succeed the predicate at all. But maybe that's not helpful for you. Maybe I only want to find products that do have a subcategory. And I assume that the other ones are maybe just under development. That's fine. But for my analysis, a product has to have a product category. We now get to the final join type, and the one you'll see most commonly used in the industry, the inner join. Inner join, we take the word left, we replace it with inner, and running that query, we go from 606 records to 397 records. These 397 records, I can confirm, all of them have a product key. So it looks like we're good there on the left side. And on the right side, I can see here too, all of our records have a value there. This is the most specific of joins because all it returns is only records where the predicate is successful. All failures, regardless of circumstance, are removed. These 397 records existed in all of the joins that we have run up until this point. The only difference is we went from 23,000 possible combinations down to 397, and the difference is just the type of join that you use. That's it. Let's recap our hierarchy of joins. Cross joins, every possible combinations of records in A and records in B. Full join, we restrict that to situations where we're evaluating a predicate, and no matter what, a record in both tables is returned at least once, regardless of whether the predicate succeeds or fails. Left join, we return every record in our left table at least once, but records in our right table are only returned if they successfully succeed on the join. The right join is the inverse of that. And finally, the inner join, where the only records returned are records that succeed the predicate on our join. Which one makes the most sense depends on your analysis scenario and also depends on the quality of your data. So be ready to play around with that depending on your circumstance. With this video, we wrap up the different types of joins with little to no use of Venn diagrams and instead using Legos to build our way through our queries the same way we build with Legos in real life. There are so many other things that you can still cover on joins, such as joining multiple tables and performance considerations and a whole bunch of other things beyond that. If that's helpful, please let me know in the comments because I do have content to address those things if people genuinely want to know. Have any follow-up questions on this or other videos in the SQL Join series? Make sure to check out the playlist for the full list of videos in the Join series. If you have any follow-up questions, let me know in the comments. I'll do my best to answer those questions in the comments, or in future videos. For now, I'm Data Bard and I'll see you in the next chapter. Today's chapter may be done, but that doesn't mean the story is over. If you are looking to work with someone like me to improve your data strategy or implementation, go to bakertilly.com/digital, fill out the contact form, and let's see how we can help you take the next step on your data journey.